Morning all, and welcome to lesson 2 of chapter 1 on partial fractions. Right, okay, so what we did last lesson was adding and subtracting fractions. So if you were to add these fractions together here, you'd have a common denominator of these two multiplied together, and your end answer would be this. Okay, now what partial fractions is all about is you're given this result and you need to put it into these what we call partial fractions. So we're going from a fraction where it's all over one denominator to here, in this case, two partial fractions. So I'm going to teach you the method today of how to do this. A lovely method. Most students absolutely love this. Just listen to the method and you'll have it super quick. So here's my key example. Listen to this method and then copy the notes down and then have a go at the next example. So what we do here to put this into partial fractions. The first thing we're going to do is we are going to write down the two denominators of our partial fractions. Now, we're going to have two partial fractions. The reason we're going to have two partial fractions is because there are two linear factors on the denominator here. And we want to know what A is and what B is. Yeah? Okay, so what we will do is, let's imagine putting this right-hand side back into one fraction. So the method I taught you last lesson is we say how many x minus 1s go into the denominator? Well, it goes in 3x plus 2 times, and we times it by a. So I'm just putting this as one fraction. Plus, how many 3x plus 2s goes into the denominator? X minus 1 times. So we've got b lots of x minus 1. This step going from here to here is vital to your understanding. Please, if you do not understand that step, you must let your teacher know to clarify that more. Now, if we notice, if I just write this out again here, okay, if you notice the denominators are exactly the same. So I could just write down that 5 on the numerator is equal to my other numerator. Yeah, because if the denominators are the same, the tops must be the same if they're the same fraction because they're equal. So if that is the case, which is the case, I'm now going to find A and B. So how am I going to find A and B? Well, what I'm going to do is if I put my value of x in here to be 1, then 1 minus 1 is 0. So the B would disappear. So let's say let x equal 1. I'm going to substitute that into this equation. So I've got 5. That stays the same, equals A, 3 times x is 1 plus 2 plus b, x is 1. So the reason I chose 1 was to make this bracket 0. So I've got 5 equals A times this 5 plus 0. So therefore, A must equal 5 divided by 5. A must equal 1. So I found my A value. Right. To find my B value, I will need to make this bracket equal to 0. Now, this is a little bit trickier, this one, but I'm sure you've realised that what I can do to work out my value of x to make this 0, what I can do is I can say, let 3x plus 2 equals 0. If I just do my working out up here, so you can all see this. Therefore, 3x plus 2 is 0, 3x is minus 2, So x is minus 2 over 3. So to make this value here 0, i.e. to make a 0, my value of x needs to be minus 2/3. Okay, so I'm going to now put x equals, so I'm going to say let x equals minus 2/3. I'm going to put that into this equation here. So we'll have 5 equals a 3 times minus 2/3 plus 2. We know that's going to go to 0. Plus b minus 2/3 minus 1. So I've got 5 equals, this is 0. Now I've just got to do minus 2/3 minus 1. So minus 2/3 and minus, that's minus 3 over 3, isn't it? Minus 1. So I've got b times minus 5 over 3. If you're not sure about that, you can do it on the calculator or do it in your head. Okay, so what's the value of b? So b will equal 5 minus 5 times, bring that to the other side, minus 3 over 5. So the 5's cancel and we get b to be minus 3. So we have our solutions for, so I'm just going to get some more paper, guys. Give me a moment. So we have our solutions for a and b now. So if I put a and b back into my original partial fractions, so a we worked out to be 1, so that's 1 over x minus 1, and b was minus 3, so I'm going to do minus 3 over 3x plus 2. Okay, so I've now changed this fraction into partial fractions. Okay, so just to recap what the method was, just to go over that one more time. What did I do? I put it over common denominator. I made the numerators equal. And then I let values of x to make the bracket 0 to find a is 1 and b is negative 3. And then I just put it back into the answer. Right, so I want you to have a go now at doing that yourself. So I want you to try this one, okay? Now it looks, this is a quadratic on the bottom, okay? So the first step you're going to need to do is factorise the denominator and then follow the steps that I just did. So pause the video and have a go at doing that, guys. So we're going to put this over a massive denominator. Okay, so the denominator is the same as it was before. Okay, now I'm going to say, excuse me, x, so how many lots of a do I want? So x goes into the denominator. If I just cover up x, it goes in this many times, the two factors that are left. Plus b goes into it, cover up the middle. Plus c goes into it, the two factors that are left. So that's how I do it. Now, we've got to now equate our numerators. Now, this step here, once I've got used to it, I tend to stop writing that step because it is so long. And I go straight into this step. There is a lot of writing here. I don't think I can fit it all on one line. My writing is quite big. Okay, so now what I'm going to do is to find my values of a, b and c by putting different values of x in. Now the most obvious one is to put x equals 0 because these two will disappear, b and c will disappear. If I do that, I'm not going to do all the method here, guys, because it's very long, okay, but you get a equals minus 1. If I put x equal to -12, I will get b to be equal to 2. And if I put x equal to 2/3, I'll get c to equal 3. So I just put those back into my original equation, and I'll have A is equal to -1, B to be equal to 2, and C to be equal to 3. Okay, so I'm just going to give you one of those to have a go at doing, and that's the end of my video for today. So this is the one I'd like you to try. So pause the video, have a go at that one. Factorise the denominator first. Okay. If you're struggling to factorise this, I'll just do that for you now. X cubed minus x, just take a factor of x out, x squared minus 1, and you can see you've got the difference of 2 squares. Okay. Now, for those of you who've done that, and you can just go straight to the answer, okay, then you don't have to watch my method, and you can go then straight to the end where I've put in what I'd like you to do at home to practice these skills. For those of you who didn't get that answer, I'm going to go through it now. So, what do I do first of all? Okay, so I'm going to put it equal to A over X plus, sorry, 1 second, plus B over X plus 2 plus C over X minus 1. Okay, I'm going to do now my steps. I'm going to say 6x squared plus 7x minus 3 equals A lots of x plus 1 x minus 1 plus B lots of x times x minus 1 plus C lots of x times x plus 1. Okay, so what values of x shall I put in? So I'm going to put x equals 0 first of all. X equals 0, so I'll get -3 equals -1a. So a is 3. Yep, I'm just checking that with my answer. Yep, that's correct. A equals 3. What value of x I choose now? I'm going to choose x equals -1 to get rid of these two. So x equals -1. So I'll have, well, -1 squared is 1. So I'll have 6 minus 7 minus 3 equals, that will disappear, that will disappear. So I'll have minus 1b times minus 2. So I've got -4 this side equals 2b that side. So b is -2. Yep, I've got that one right. Okay, b is -2. And then my final one to work out c, if I put x equal to +1, x equal to +1, so I'll have 6 plus 7 minus 3. That will disappear, that will disappear. So I'm putting it into here. C times 2. Yep, 1 times 2. So I'll have 10 on this side, 2c on this side, so c is 5. Okay, and that gives me my final answer when I put them all back in. Right, okay, so I'm hoping linear factors, either 2 or 3, A, B, or A, B and C works well for you. So I haven't set you loads to do because they are quite long. Optional work is the challenge. I'd love to see how many of you can do the challenge. And here's your compulsory work from 1D. Thanks for listening and look forward to seeing you tomorrow. Bye-bye. So I'm going to do this one with you. You can just skip to the end and check your answer if you want to save time. But if you think you struggle with this, then listen to this one again. So I've got 7 minus 3x on the top. I'm going to factorise the denominator. X must be 4 and 1. That must be minus, that must be plus. Okay, so I'm going to then put that to be a over my one factor on the bottom plus b over my other factor on the bottom. Okay, now I am going to put this over a common denominator, which would be the same as my original denominator. A lots of x plus 1 plus b lots of x minus 4. So I can now say that both my numerators are equal. And now I'm going to sub in values for x to get rid of both these brackets. So the first one I'm going to do to get rid of b, I'm going to say let x equals 4. So I'm going to sub that in. So I've got 7 minus 12 equals 5a. So negative 5 equals 5a. So a equals negative 1. And then going to sub in a value for b. So I'm going to say make this one equal to 0. So I'm going to say let x equal 9 minus 1. That will make that 0. So let's sub that in. 7 plus 3 equals, that will be 0. b times negative 5 minus 1 minus 4. So I've got 10 equals minus 5b, which implies b equals negative 2. So that's my solution for b. Okay, I'm now going to sub in those answers. So I've got a and b. I'm going to sub those back into the original partial fractions. So my answer will be a was negative 1 and b was negative 2. So I'll just put my negative sign here. And that's my solution, guys. Well done. I'm sure you got that right yourselves. Okay, so that is basically what this exercise is all about. Now, there is one further question I'd like to go through, which is when you have 3 linear factors. Now, the method is identical. It's just a lot more more algebra involved here. You've just got to be really careful with your algebra. So, and in this case, I'm sure you can see you're going to have now 3 a, b's and c's. So, because I'm going to have a over x plus b over 2x plus 1 plus c over 3x minus 2, because I've got now 3 factors on the bottom. So, when I put these back to the common denominator of what I started with, okay, this time I'm going to say, well, x goes into, if I cover up x will go into my denominator this times this times. So I've got, I'm going to probably need quite a long, yeah, okay, so x goes into my denominator, 2x plus 1 times 3x minus 2 times. So I've got a lots of 2x plus 1 times 3x minus 2 plus b lots of, so I'm going to, this is what my b is over 2x plus 1, so I'm left with these 2 factors, b x times 3x minus 2